Hi,
Hi,
how are you?
I'm good. How are you?
Doing great, Ariana. And got the news from your mom.
Hmm?
I got the news from your mom that you did well over your midterms. Good
Yeah,
job. All right, what you get?
thank you. I got an A in math.
Ah, great. What did you normally get before we started?
I usually got around B's during the with the little check-ins and stuff, so this was
Right.
pretty good.
Okay, that's good to know. All right, so well, I think you deserved last week's break then. All right, so what are we doing today?
um, I didn't. We don't have like any specific file for
Mm-hmm.
what we're currently doing in like math that I really wanted to do.
Uh-huh.
So hold on, I'm trying to remember it's like the remainder theorem and the factor theorem.
Okay, let's write these down. Remainder and factor theorem. Oh, by the way, Ariana, is it okay if I
Hmm?
stream this lesson? The only thing that we would see on the stream is my face, and they would only hear your voice. They won't see you at all. Is that okay?
Oh, okay, okay, that's fine.
All right. I'll give you a link to the stream in case you find it interesting later. Yeah.
Mm.
All right. So let's
Where do
go.
you stream on?
Well, uh, I'm testing everything out. So YouTube, Facebook, Twitch, everything. I'm testing it out,
All
see how it
right.
goes. Okay, so remainder theorem.
Okay.
And what was the
Do
other
I
one?
need? Um. Fuck. It's like. Wait, wait. Sorry.
No
Factor
worries.
theorem.
Factor theorem. Okay. Okay. Uh. Okay. Um. Okay. So while we're waiting, I'm going to just set this up real quick. I'm gonna send you the link to the Jamboard so you can join.
Mhm.
Here we go. Just so you know, I ask all my students that question if it's okay to stream it.
Oh, okay.
Yeah, the only
I
thing
don't
that
mind.
yeah, the only thing that everybody would actually have access to, just so we're clear, is your voice and your name.
Ah, okay. Okay.
All right. Uh, okay.
I need to send request.
Right. Okay. So hold on. Let me also just fix the settings here. So, editor and done. Let me just double check.
Nope. I'm in now.
Okay. Good. Um. Okay, so basically these two things. All right, so I'm just basically checking my notes, checking some notes online here, just to make sure that I have the correct information.
Mhm.
But these two things are essentially the same idea, the same thing.
Yeah.
Okay. Specifically, yeah. Um, specifically that the factor theorem is a special case of the remainder theorem. Okay. Um,
Mhm.
All right, so let's take a look at what the remainder theorem actually is. How do you understand it?
Um, from what I've actually written down is
Mm-hmm.
that if a polynomial is divided by the x minus r, the remainder is r.
Mm-hmm. That's correct. Okay. So,
Okay.
all right. So let's kind of look at an example here. So, let's write that again. Let's write that down first again. You said if a function f is divided by what? Some
I forgot what it's called, but it's like the x minus r thing.
okay.
Like
Okay.
the given or something.
Basically, if a function f is divided by some other function, okay, is divided by some other function, let's call d, okay, where d here is what we're gonna use d to represent the divisor, okay.
Okay.
Okay, then
Mhm.
the result will be basically two new functions q and r, okay. Functions q and r, so that what we get now is this. So f of x is equal to d of x, so that's our divisor, this is our quotient, q of x, then plus the remainder, r of x. Okay, so that's the remainder theorem. The factor theorem here is going to give us a more specific case on what that r is, okay. So I just want to note that here, the remainder theorem gives a more specific answer to the value of r, okay. Okay, so all right, so let's take a look at the quick example here. All right, okay, so let's think of, can you give me like a polynomial function? Let's make it a bit easy to work with. Let's work with multiplication first. So let's start with, let's say what is x plus 3 times x minus 5. Okay,
So
if we multiply these, what do we get?
you have to like foil it, yeah?
Exactly, you do foil.
I'm just gonna write it down
Okay,
here first.
great. Okay, while you're working on that, I want to ask, which one would you like, which link would you like to have, the Facebook, the YouTube, or the Twitch link?
The YouTube.
YouTube. All right, I'll give you the YouTube link.
Wait, no, this is supposed to be x2. Or x squared, actually, I think. Yeah.
Okay, I'm giving you the link to the actual stream. You can get the channel from there. So that's the stream right there. All right, let me see your answer. Okay, this is correct. Right? Okay, so this time I'm going to add some function. I'm gonna add plus 3x minus 2. Now let's just give that like that. So this is gonna give us an overall function of x squared minus x plus 13, right? And as you can see here, this is not an easily divisible function, right? Okay. So what we'll do now is we'll reverse the problem. So reversing the problem does this. Okay, if we start with, let's color that blue now. If we start off with x squared minus x plus 13, and let's say I'm gonna divide that by either one of these two older functions. So let's pick the easier one. They're both easy. Let's pick the first one. So let's pick x plus 3, right?
Okay.
All right. We should get an answer that this our final answer should be x minus 5, then remainder 3x minus 2. This is what the theorem says. Okay. Now, let's close that for a while. Okay. So what we can do is, in order to divide this, there are several techniques to do division. So we can either do long division, right? Or we can do what's this, synthetic division. There's another technique, but I think these are the two more common ones. Synthetic division. Now, which one have you already learned?
We've learned both, and I like to intertwine between them.
It really depends on what looks easier to apply, right? So, all right. So what I want you to do is divide this x plus 3, this x squared minus x plus 13 by x plus 3 by using either one of these. Okay. Let's put this on the next page. So I'll just write it here again. Okay. So x squared minus 3x plus 13. Divide this by x plus 3. There.
Okay. I think maybe synthetic might be easier.
Yeah, I think so. I think so as well.
So then you leave it would be -3 because like it's supposed to be x minus. Yeah.
Correct.
And then 1 minus 3
and
13. Yeah.
Okay, correct. Okay.
Do that weird thing.
All right, go ahead. So while you do that, I'll just explain to the stream what's happening. So in synthetic division, anyway, no one's watching the stream. I just want to say it out loud in case somebody watches it. Yeah.
It's alright. I'm like on it. I'm just like looking.
Right. Okay. So for those watching the stream, if you're not familiar with this, synthetic division is what you need to do here is you look here. These are the coefficients of the dividend. That's what you write here. So this is 1. Then this is -3 here. Then this is plus 13 here. Then this is -3 because this should be in the form x minus a. This is a. Alright, so our a here is -3. That's why this is -3. Then when you do synthetic division, it's very similar to normal division. You just basically start here. You take your first term, put it down. You take this new term, multiply it by that to get this. To get this. Then you add. Instead of subtract like you would in normal division, you add. So -3, -3. Okay.
-6.
-6.
And then
hold on. Okay, there we go. Yeah, that's correct, right?
Oh, okay.
Okay.
It's just like a big number.
Well, yeah, kind of big. But let's compare this to our actual original functions. It's x minus 5 and 3x plus 2 and x plus 3, right? So let's write those down. So we had x plus 3, x minus 5, and then, what was the last one? 2x minus 3. Or is it 3x minus 2? 3x minus 2. The other way around.
2x minus 3?
This is 3x minus 2 here.
Oh.
Okay. 3x minus 2. Alright, so we have our x plus 3 definitely there. Right? The problem is, this is 6, this is minus 5. There's something a bit off with what we just did. Right? But let's take a look at if there's anything I did wrong with the setup. Hold on.
Alright.
Okay, 15 minus 15. Oh, okay, sorry. Yeah, I did do something wrong with the setup. This should be minus 17.
17?
Yeah, because -15 here and minus 2 here, so minus 17, right?
Oh,
okay. So I set it up wrong, but just so we're clear, the division was done correctly with 13. So if we go back and change that, there should be 17. This is x squared minus x okay, this should be x squared minus x. Okay, so there's another mistake in the setup. It should be minus x. Alright. So let's redo the synthetic division real quick.
Okay.
This is minus 17 here. Let's just fix those right now.
Should I just delete everything?
Yeah, no need. Not everything, but just these bits.
Okay.
Just this and this and this. Yeah, we'll delete this. Alright.
Keeping the 1.
Yeah. Alright, so again, for the benefit of those watching on the stream later on, so we'll just rewrite the minus 1 here and the 17 here. Okay. Alright, so Ariana, go ahead and do the synthetic division for everyone to see.
Okay. It's minus 1, right?
Mm-hmm.
Okay.
Let me make sure again, just to be sure. X squared. Yeah, that looks right. That looks right. Okay. Okay. Something's still wrong. I wonder what it is. Okay, but anyway, like I said, the synthetic division here is done properly. You still have to multiply this and this to get -3. So -1 here plus -3. Again, you add those, gets -4, correct? So -4 times -3 is 12. Then again, you add these two to get 29. Alright, let's assume that this is... Well, I'm gonna assume this is the correct answer since this is done, right? The problem is, where did this come from? And where did this come from, right? Where did this go and where did that go? Now, one way for you to think about this is... this is another possible answer. So, this... Earlier, let's write that again. So, x squared minus x minus 17... This is our f of x, right? Okay, our divisor is the x plus 3. Okay, the quotient here is the x minus 4. Okay, and finally the remainder is 29. Not the whole 29 over x plus 3, because that doesn't turn it into a remainder when you add the denominator here. So the remainder is only 29. Okay.
Okay.
All right. So just 29. That's the remainder. So it's basically just like normal division with numbers, right? You divide, you get an answer, you get a remainder, right?
Okay. Yeah.
All right. So one important thing about either one, whether we're talking about either the remainder or the factor theorem, is that the remainder will always be one less. Okay, something's missing here. The degree of r. Okay, let's add that term. The degree of r will always be one less than the divisor d. Okay. So in our example, again, degree, for those who don't know, is what? Degree just means the largest exponent of x. Okay, let's exponent of x. Okay, so again, that's what degree means. So in our example, the degree of d is 1 because our largest exponent of x is x. Our function d is x plus 3, right? So this is 1.
Okay.
Okay, and that's the degree. So this
Mhm.
means the degree of r will be 0. That 0 is 1 minus 1. Okay, and where did this one come from? Comes from that. Okay, and that minus 1 is always
Yeah.
there. All right, so which again makes sense. If we go back to real numbers, not functions, it's basically the same thing. What's gonna be 4 cubed divided by 4? Let's even make that bigger. Not let's say that this is cubed and then this is 4 raised to 8, right? This is gonna give us that's gonna give us what? 4 raised to 5, right? So you will see here that this is always smaller than that, but you can always think of this as 4 to the 4 times, not 4 squared times 4 squared. That's a possibility, or you can always say that this is 4 cubed times 4, right? Okay, now what's important in the theorem is that this is 3 and this is 2. That is the important thing here. It's not this and it's not that.
Okay.
Okay, so again, it's just putting an analogy with real numbers to help you kind of remember it. Okay? All right. Okay, now so anyway, that's the division part, right? What does the remainder theorem actually mean now? So this is now how we explain the remainder theorem. Remainder theorem. Okay, the idea here is you're choosing your function. Okay, you're choosing your function here. Now if you have a function f of x, and then we're gonna choose a function, let's say c, x minus c. Okay, the c is a constant. Okay, now if or rather I'm gonna say it like this. Okay, if I'm gonna divide this by some function x minus c, in other words, it's a degree 1 polynomial, right? This is gonna give us q of x, a new function, plus another function r of x. This one actually has the x over c, right? X minus c here. So if we multiply the whole thing by x minus c, right? So that cancels out, and we're left with f of x is equal to x minus c times q of x, plus r of x. Okay, now this is the actual remainder theorem here. Okay, this simply means what? Okay, this simply means we can choose x to be anything, right?
Yeah.
Okay, now remember this. This thing is degree 1, right? Degree 1.
Degree 1.
Okay, what does this mean for r of x? Let's go back here. If you divide a function by another function, the result will always have 1 degree lower, right?
Yeah.
So again, in other words, what's our divisor here? Our d is equal to x minus c, and the degree here is 1. Degree 1. So what's our remainder? The remainder must have degree 0. Exactly. So in other words, since this is degree 0, it means x raised to 0, right? So this means this is just a constant. And therefore, we now have the final form of the theorem. F of x is equal to x minus c times q of x plus some constant.
Zero?
Nope, not 0, but plus some constant r. The r here now is a constant.
Ah.
Okay? Because remember, this particular thing was your divisor.
Okay.
Okay. So, okay. So we have this now. We have one more step to go to finally get to the remainder theorem. What if? What if x equals c? So what if x equals c? So we put c into all of the function, into all where we see x, right? So this becomes f of c on the right, on the left hand side, right? F of c equals x minus c is
0
times q of x, q of c, right? Now, no matter what q of c is, because of that 0 here, this is 0, right?
Yeah.
Okay, and then plus r. In other words, you can find your r, you can find your remainder by finding the c, or you can find that constant by knowing what the remainder is. Okay, so this is the remainder theorem. I'll type this in. Okay, so the remainder, this is the remainder theorem. So we just proved it basically, right? Because that's what you do with theorems. You try to prove it via what's this? Logic, right?
Yeah.
Okay. So the remainder theorem, let's just finish this off. Let's say it in words. Okay. Okay. If f of x, okay, I'll just write it like this.
Okay.
I'll just write it here. So f of x divided by x minus c is equal to q of x plus f of c. Why? Because of the fact that this is equal, we've changed that there. This is substituted in there. So this is the whole remainder theorem. In order for you to find the remainder of any function, you just find that function at c. Okay. All right. So let's go back to the one we were doing. So we did.
Okay.
So let's just copy the equation again. We got 29 out for our remainder here, right? So what we'll do is we'll put our value in there. X squared minus x plus 17. So x squared. X squared minus. Oh, sorry. Was it minus or plus? Minus 2x plus 17 over x plus 3. Okay. Let me just check if this is correct from what we have copied. Minus x, not minus 2x. Okay, so minus x plus 17. So what's the remainder here? So again, let's identify this is our f of x, right? And then this is our divisor, d of x, right? And from our d of x, we can calculate, we can see that c is equal to 3. Oh, sorry, negative 3.
Yeah.
Right?
Oh, yeah.
Okay. So what's our remainder here? The remainder will be equal to negative 3 squared plus minus 3 plus 17. So this is gonna give us 9 minus 3 plus 17. That's gonna be 6 plus 17. 23. Was it the same?
Yeah.
We got 29 earlier. So we still didn't quite get what we wanted. We're getting different answers.
Oh no.
No, why? Why are we getting different answers?
Oh no.
I don't know. All
On
right.
my side, it's blurry. Hold on.
Mm-hmm.
Like the slide 3.
Yep.
Oh, there we go. Never mind, it's good.
Okay. All right. So this is what we'll do. I'm going to do the long division right here, right beside it. I'm going to do it myself now. Okay.
Okay.
All right. So let's do the long division here. So -3 is our divisor. We're going to get 1, -1, and 17. I'm just going to draw that dotted. I prefer dotted lines over that double line there, but same thing. So 1, 1, 1. 1 times -3 is -3 here. That should give us 4. -4. Yeah, that gives us 12. This is 29.
Huh.
Hold on.
Does this have to do with anything with the plus 3x minus 2?
Probably. Let me scan this again.
Raw?
Yeah, you can. Let's try to do it the long way.
Long division or like
Long division. So
okay.
Let's try long division here. Let's see what answer we would get. So
Okay.
So let's do long division. Okay, you do it. Go ahead. You do it.
Okay.
Okay.
2 Oh no. And then x plus 3.
Okay. All right.
Times that by x.
Correct. All right. Keep going. For again, this is
Okay.
for the stream. How did you get this x? We did x squared divided by x. So x squared divided by x gives us x. And then what's happening here now is this x is being multiplied into the whole term. So this is where we get x squared 3x here. Now we do it like normal division. We subtract. Okay. Why? In order for the x squared here to cancel out. That's why these got canceled out. Now, since that's a subtraction, this is x minus 3. That gives us -4. Then we do the same thing. We bring everything down there. Now, we repeat the process. This is 4x and x. That's where we got 4. 4x divided by x is 4. Then we multiply this 4 to the whole thing on this side here.
It's 12.
Okay, we get the exact same answer, 29, right? So
What's
this is
going on?
correct. This is correct. So what's going on? Where is our mistake? Okay, but at least the theorem, we kind of get to see the theorem at work. Now, we are at a loss here. What's going on? Why is it? What is going on? Why is it not 29? All right.
I'm gonna look at the original problem.
Yeah, let's look at the original. See if there's any mistake I did in the
x plus 3, the foiling. The 3x minus 2. Wait. Where did you get the 3x minus 2 again?
I just made that up.
Oh, okay.
Okay, I think we better do another one without making it too complicated like I did. Yeah? So,
Okay.
alright. Let's just keep it clear. So, let's do that other thing again. So, let's multiply two polynomials again. So this time I'll still make it squared. So let's just do x minus 15. Okay. And then x plus 1. So if we start off with this, what's this gonna give us?
So FOIL, right?
Yep,
Yeah.
let's do FOIL.
X 2.
X squared.
That's minus 15, right?
Uh-huh.
Or is it okay, minus 15?
I'll just rewrite that real quick.
Inside. First. Wait, no, I did something wrong, huh?
You did something wrong, yes. So you did x
I
squared.
just realized.
Yeah, you were right so far with x squared.
Oh. First. Outside.
Outside, correct?
Inside. I knew I did something wrong. Less. There we go.
Alright.
This would be minus 14 x. So x 2 plus, or no, minus.
Minus, correct.
14. X minus 15.
Okay. Now, what I'm going to do now is I'm gonna just add a number to it. So
Okay.
what's this? What is x squared minus 14? 14x minus 13 divided by, let's do the x minus 15 bit. Okay, what's that equal to? So again, let's compare synthetic, long, and and long divisions. So the two divisions, and then let's compare that to the theorem. Okay,
I'm gonna do synthetic first.
All right. So Ariana, you do, which one would you rather do, synthetic or long division?
Synthetic.
Okay, you do synthetic, I'll do long. Okay.
Okay.
All right. So for now, I'm not gonna say anything. We just work on it together for the. Let's see what happens here. So,
Okay.
so we. Okay.
Oh wait.
No, all right.
This wouldn't be negative.
Okay, so this should be plus here, right? All right. So in both our cases, we agreed that the remainder is 2, right?
Yes.
Okay. How did we get a remainder of 2? Because if you think about this, I added 2 to both of the. I added 2, and that's why it became 13 here, right? That makes that I think that makes more sense in this particular example. So.
Yes.
All right. So in this case, let's do the remainder theorem.
Okay.
So let's do that on the. Hold on. I'll copy this first. I'll just take a screenshot of this and put it onto the next slide. So that way we don't make a mistake in copying. All right. So we have this particular problem. Let's use again the remainder theorem. So we have to identify our f of x, and we identify our c. Okay, and then the remainder will be equal to f of x, f of c.
Oh, okay.
Okay. So what's our f of x here?
2.
No, not quite.
Okay.
our f of x is the dividend.
The 15?
This whole thing is f of x.
Oh. Oh.
Okay. So always the top number, the dividend, is our f of x.
F of x. Okay. Yeah.
Okay. Our c is this. Negate.
Mm.
Okay.
So just 15?
That's correct. That's gonna be 15. Okay. So what's the remainder? We put our 15 into all the x values.
Ah. Should I write that down?
Yes. Alright, so that's gonna be 15 squared, correct? Minus 14 times 15 minus 13.
Use this on my calculator.
Yep. Actually, there's a shortcut if you can see it.
Wait, would it just be the remainder?
Yes. It should give us 2.
Oh! Yeah, I got 2.
It is, right? Now, what's my shortcut here? A lot of us would probably do this in the calculator. Okay, I have the calculator here. So what most of you will probably do is, I'm showing this on the stream on the calculator, yeah? So 15 squared.
What?
Alright, then minus, then what you did was probably 14 times 15. And that's gonna give you a difference of 15, right? Difference of 15. Then minus 13 gives us 2. And there's a remainder, right? So, shortcut here. I'll show you a shortcut. I'm not gonna write this as 15. I'm gonna write it as 15 times 15.
Okay.
Why? Because I can factor out 15 here, right?
Ooh.
Then 15 minus 14. Then minus 13. This is gonna be 15 times 1. See? No calculator needed if you know the shortcut. 13. That's gonna give us 15 minus 13 and equal 2. Oops, why did I write 3? 2. Alright. Okay. So, alright, if you can see a shortcut, go ahead. But again, no issues if you use a calculator. Okay, now, the last thing about this, that's the remainder theorem. The factor theorem is a special case here, okay? The factor theorem is this. Okay, use remainder theorem, right? Theorem to find remainder, right? To find a remainder. Now this one's pretty obvious, but we can prove it, but it's pretty obvious. If the remainder is 0 for any number, then that means the divisor and the dividend couldn't divide the divisor evenly, right?
Okay.
Alright, so basically, if r equals 0, then x minus c, okay, then x minus c is a factor of f. Again, if we go back to real numbers, if we say 14 divided by 7 is gonna be 2 remainder 0, right? Then 7 is a factor of 14, right? Again, this is an obvious case, but this is the exact same point that the factor theorem is saying, but instead of saying it with numbers, we're saying it with functions. Okay, so the important part is that remainder is 0, 7 is a factor. Okay, so alright, so what will we do now? We're going to do the example. So let's do the other example where we have x squared minus 14x then minus 15, right? X squared minus 14x minus 15, right? We know that this is
Mhm.
equal to x minus 15 times x plus 1. We've established that before, right? So what
Mhm.
is, so let's just do it like this. What is x squared minus 14x minus 15? Not 13 this time, but 15 divided by, let's split the x plus 1 bit, x plus 1 factor today, in this case, right?
Mhm.
So again, we can do long division, we can do short division, synthetic division, or we could just use the particular thing that, you know, we started off with this.
Mm.
Okay, what is the remainder first, right? Of
Uh-huh.
this. Now, what we'll do is
Mhm.
we're again gonna do the exact same thing as before. We're gonna do, what is f of x here?
F of x is the top thing, which is
Top thing.
x2.
Minus 14x minus 15. Okay, great. What is our c?
-1.
Negative 1. Correct. Okay, so what is f of c?
Um,
That's gonna be
negative
negative 1.
1,
Okay, you go ahead, you
2.
show it
Oh,
here.
I was gonna
Yeah, go
put
ahead,
the
just show
thing
it.
on there. Okay. Minus 14, -1, minus 15. Just be like 1 plus 14 minus 15. 0.
0. Which proves our point. X plus 1 is a factor of the polynomial x squared minus 14x plus minus 15. Okay, we can do this, we can do the exact same thing. If I change this to 15 or negative minus 15, we will get the exact same as same remainder.
Okay.
Okay, I'll do that one now. So just to, you know, just show it formally. So c equals 1 here, and if c equals negative negative 1 here, negative 1, just rewrite that. Okay, all right, so this is negative 1, and then if we put 15 now as our c, then we do exact same thing. That's gonna be 15 squared minus 14 times negative times 15 minus 15, right? So if we can, again, I'll just do the mental shortcut that I usually like doing here. They're both negative 15.
Okay.
Okay, so I'm gonna get here 15 squared minus 14 plus 1 times 15. Where did I get the 14 plus 1? Factoring this out. Okay, so again, factoring these out gives us that 14 plus 1. So that's gonna be basically 15 squared minus 15 squared, also 0.
Ah.
So we've proven, well, not proven, we've shown that the remainder theorem works. Okay. All right. So I'll just put it here again to recap. Yeah. So
Yeah.
remainder theorem. Actually, let's start with that. Let's start with the function. So if f of x over x minus c is equal to some function q of x plus some remainder r, right? Then one of two things. R is equal to f of c. This is the remainder theorem. Okay. Or r equals 0, therefore x minus c is a factor of f. This is the factor theorem.
Ah.
So it starts with the same idea, but the interpretation is a bit different. Okay. All right. Is that clear, Ariana?
Yeah.
All right. I'll just give you one last problem, and then we're done for today. Okay. This time
Okay.
I'm not gonna give you the two functions we can do. Okay, I'm gonna give you the exact just write it off right now. Okay, so I'm gonna say,
Okay.
let's say I have x, again we'll keep it at x squared.
Keep it simple.
Yeah, keep it simple. Oops, hold on. That's not there. Let's make this 18.
Ah.
There. What's that equal to? Find r. Okay, find the remainder.
So.
And then the next question is x minus 4 a factor?
Okay. So this would be x 2 minus 9. 18. And the other one, no, it's supposed to be fx.
Okay, great.
And then the next one is fc, yeah?
No, it's just c.
Oh, it's just c.
Yep.
Oh.
Because the third one is
And
fc.
Okay. So, that would just be 4.
Correct.
And then f of c would be 4 squared minus 9 4 plus 18. Oh, that doesn't look. There we go. Just gonna do that on calculator.
Go ahead. Alright, so this is for the stream, yeah? So far this is correct. So, okay, what's your final answer?
-2.
Alright, so I'm calculating it on the stream. Minus, okay, 9 times 4. Correct? The final answer is correct, -2. Okay?
So, for the second one, it would be no, right?
Alright, so no, it's not.
Nope. And then...
Okay, that's correct. All done.
No in big letters.
Alright, good. Okay, so I think you got this already. We'll just practice this again further later on if you need to. Otherwise, just send me again as usual. Just send me whatever you would like to study before we start, yeah? Next week.
Alright, thank you.
Alright, see you later, Ariana. I'll see you soon. Bye bye now.
Bye. Have a good day.
Alright, you too. Okay. Alright, so that's the end of that stream. So again, that was more on math, specifically the remainder and factor theorems. Now, I'll be honest with you on the stream. I had to kind of review this on the fly, but here's the thing, once you understand math, you don't have to totally remember everything in math. You just have to be able to understand how it works, and once it's done, like I've shown you, it's much easier to explain it. Okay, so again, understanding the math is gonna be a big help compared to just memorizing what these theorems are. Okay, so hope you learned something, and we'll end the stream here. I'll see you on the next one tomorrow. With that, see you later. Bye bye now.